In this interview, we're going to talk about JavaScript best practices, getting started with Node.js, and ending poverty with code. Hey fellow coders, my name is Christoph Limpeler. I'm the host of ScalarCode.com, where ambitious developers teach and share their experiences. Now today's ambitious developer wants to end poverty with code and teach us better ways of coding JavaScript. His name is Eric Elliott. He was a computer scientist for Adobe Creative Cloud team. He was also a JavaScript lead at Tout, which is a video network for content publishers. He's the author of a book called Programming JavaScript Applications, which we're going to cover quite a bit in this interview. And on top of that, he teaches JS and speaks. And Eric, it's a pleasure to have you on the show. Welcome.
I'm glad to be here.
Yeah, it's great to have you here. All right, so let's give people a better sense of who you are by starting out and talking about what kind of jobs did you work on at these different companies?
Sure. Back in the early 2000s, I ran a consulting firm. Was basically helping people create better software products and optimize conversion funnels and viral loops and things like that. So if you're not familiar with the viral loop, it's just kind of the way that you build in sharing into your applications and a measurement then of the viral factor of that application.
Yeah.
So I spent several years doing that. Then I took a little break and shot photos of famous musicians, and then I jumped back in, what was it, like 2010 or something? I went to work for Zumba Fitness in Miami, and then that's when I figured out that a lot of people need to learn a lot more about JavaScript because there's a huge talent gap. There's not enough people who know enough about JavaScript to really contribute productively to a large application. Mm-hmm. So at that point, I decided to write programming JavaScript applications, and I continued to work with companies on building JavaScript applications, very large, and some small, but mostly large applications with tens of millions of users or more. So that's kind of a specialty.
I'm trying to figure out the timeline. Did you work for Adobe before or after Zumba? Was Zumba the last?
Adobe was the most recent.
Okay. Are you still working there, or are you?
No, I left Adobe and started working on my courses full time.
Yeah. Okay, that's what I thought. Mm-hmm. And as you said, JavaScript is really growing. I mean, it's always been a very important language, but it's growing every day in importance with new platforms like Node.js and that sort of thing, which we'll talk about in just a little bit. But first, I want to know, when did you get started with programming?
I started about 5 or 6 years old.
Wow.
A friend had a bunch of computers in their office, and I used to go and just play a bunch of computer games, but eventually I wanted to be creative and make my own. So I started programming text adventure games, which I thought would be really easy because there's no graphics, but it turns out that interpreting like human sentences is like one of the hardest problems in computer science. So I kind of jumped into the deep end right from the start.
Sounds like it, especially at such a young age. Wow. I'm trying to think. When I started, I think I was about maybe 12 or 13, so about twice 6 years after you did. Let me see, what was I doing? So I think I was, it was Visual Basic. That's what I started doing. Visual Basic. I was playing StarCraft. I don't know if you ever played StarCraft or not, but they had the online chat, if you remember, and you could have bots. You could have clans with bots and that sort of thing. And I tried programming one of the bots, but the only thing I couldn't do, it could do everything under the sun except connect to the actual server. So it was the most useless bot possible. But anyway, I gave up too soon, unfortunately. I'm sure if I hadn't, I'd be a much better programmer today. But wow, you started really young. That's cool. All right, so as you said, as we just talked about, JavaScript is really growing in importance. And JavaScript, as I understand it, is an object-oriented language, but not a class-based object-oriented language, which is different from what I'm used to coming from a PHP background and that sort of thing. And in fact, you told me on Twitter that a lot of times you have to untrain bad object-oriented habits from people that do come from a background like mine. So I think that's why it's really cool that I'm doing this interview, because that's exactly the type of background I come from. And so I think this is a good use case of the types of people you've trained and are still training today. So let's start by talking about the differences between class-based object-oriented and JavaScript object-oriented. And you talk a lot about prototypal inheritance and why it's so much better than classical inheritance. First of all, what is prototypal inheritance?
Prototypal inheritance just means that you're inheriting from an example object rather than from a class. Okay. So it's objects inheriting from objects instead of classes inheriting from classes, and then you have to crank out an instance.
So what's wrong with inheriting from classes? Why is prototypal inheritance so much better?
So classical inheritance doesn't have to be as bad as it is.
Okay.
But it's really built on the premise that you have a single ancestor that you inherit from, right? So it creates a class taxonomy. So and inside of science and classification and classification theory and things like that, there's actually two different kinds of taxonomies that they work with. There's prototypes, which is where they basically find like an exemplar of that class.
Okay.
And then they associate things not in black and white, but on a scale. Like this thing is 50% like this other thing, right? And classes attempt to create like this rigid structure, like it's either this thing or it's not. You know what I mean?
Yeah.
So back in '94, I think, the early '90s, or the mid '90s, somewhere in there, a book came out called Design Patterns, which is the elements of object-oriented or reusable software design. Get the title wrong because I call it the Gang of Four book, right? Everybody does, really. And it's been referenced by like a million different articles and talks.
Yeah. Oh, yeah.
Like so in that book, they had two foundational principles that they built. Like everything in the book is kind of built on top of these ideas. And the one idea is favor composition over class inheritance. And what that means is that instead of just taking like a class and subclassing that so that you create an relationship with that parent class, instead of doing that, you can take bits and pieces from various sources and pull them together, compose them into a new object. Okay. So and that, if you Google composition over inheritance, you'll see a bunch of articles on that topic.
I see.
But that's one of the foundations of that book. The other one is programmed to an interface, not an implementation.
Yeah.
Right. And class inheritance kind of violates both of those principles, right? So when you subclass something, you're not programming to its interface. You're actually making the implementation of that thing a big part of the implementation of the new class.
Sure.
Right?
Yeah.
So it creates an is relationship versus a has relationship or a uses relationship, right? So it's like saying my dog object, whatever, if you've got like pets in a pet store or something, my dog is an animal, right? Which is just fine. But if you're making the game Clue, right, and you start with tools and weapons, you can't finish the game because a lot of the murder weapons in that game are both tools and weapons.
Sure, I see what you mean. Okay.
So the biggest problem with class inheritance is that most of the things that we model in software don't follow a strict taxonomy. They don't have this strict hierarchy of parent and child You know what I mean?
Mm-hmm.
It's not a bunch of relationships. In reality, we have a bunch of like uses relationships or has relationships.
So is it still useful in smaller applications? Would you still use something like that in a smaller application, or would you go ahead and always use prototypes in your personal experience?
I would always use prototypes, especially in JavaScript, because it's just easier to use prototypes in JavaScript.
Okay.
So ES6 has the new class keyword, but there are a lot of issues associated with using the class keyword. For example, in ES6, if you try to invoke a constructor without the new keyword, it's going to throw an error. It's going to cause problems, right? But if you invoke a constructor with the new keyword, you're coupling all of those callers to the class instantiation model, right?
Mm-hmm.
So you're saying that these things are always calling constructors, right?
Mm-hmm.
Which makes it harder to, for example, swap that out and replace it with a factory function, right?
Mm-hmm. Speaking of factories, can you explain them a little bit better and go into more detail as to what they are?
Sure. So a factory is very much like a constructor function, but in JavaScript, it's just a normal function that returns an object. And in JavaScript, any function can return an object. You don't need constructor functions at all in JavaScript because any function can act like a constructor function and do the job of a constructor function.
Okay.
So, and the big difference between a factory and a constructor in JavaScript is that the factory doesn't need you to use the new keyword, which means that you can decouple the places that you're calling and instantiating from the method of object instantiation, which makes your code more flexible.
Mm-hmm. Now, so we understand that using classes and constructors and stuff like that, you have a lot more tight coupling, so that's definitely not good. But is there also a speed difference? Is there more overhead using classes, or is there more overhead using prototypes? How does that work?
Sure. So just to address that question, if you're worried about the speed of object instantiation or property access in JavaScript, I guarantee you're optimizing the wrong things. Mm-hmm. Because in JavaScript, a tiny portion of the application time is spent running any JavaScript at all. Mm-hmm. And a very, very, very small portion of that time is spent creating objects and accessing their properties, right? So this is not the bottleneck in your application.
Okay, I see.
Yeah, in JavaScript, the cheapest laptops around can access millions of properties a second. So, and I don't think that your program is doing nothing but accessing object properties all day long. That's not what it does, right?
Sure.
Your program spends most of its time making network requests or drawing to the screen or doing these things that actually create bottlenecks in your application. Mm-hmm. So what you need to do if you're worried about performance, forget about pre-optimizing anything, right? And just measure the performance of your app. Profile it. There's Paul Irish has a bunch of professional profiling tips. If you go to his site, his blog, he's done quite a few of kind of deep dives looking at applications and websites in the wild and figuring out what can be done to optimize those and make them run faster. Yeah. Right. So go watch some of those and see what actually causes bottlenecks in JavaScript. Mm-hmm. It's not objects, right?
Yeah, Paul Irish has some really good stuff. I'll try to link some of them below the video in the description. And I want to talk a little bit more about speed and bottlenecks and that sort of thing in just a little bit. For now, I want to pull back and talk a little bit more about interfaces and that sort of thing with tight coupling. Sure. And in fact, in your book, you had a really good example that I liked a lot where you said classical inheritance is kind of like IKEA furniture, where you buy the pieces at IKEA and there's a manual and you have certain pieces that go in certain areas, and if you try to modify that piece or if you try to put it in the wrong area, you're not going to have the furniture you purchased. Whereas on the other hand, with composition, it's like Lego blocks, where you can take any Lego and plug it into any other Lego. At least I think so. I haven't really played with Legos in a while, but I think that's how it works. You can take any of them and move them around, so you can have different modules and shift them without actually breaking the application in this case. So I like that example a lot. Can you explain a little bit more what interfaces are, just to make sure everybody's on the same page?
Sure. So an interface, in other languages, there's a concept of an interface as something that the language provides for you that makes guarantees about a contract. So an interface is just kind of the way that you interact with that object or that class of objects in your program, right? So think of it as a contract. Like, this object is going to supply such and such methods and such properties, and you can count on that always being the case, right?
Yeah, exactly.
So JavaScript doesn't have interfaces. JavaScript doesn't even have user-definable types that are standardized and that you can do static analysis on, right? So, but you still want to make sure that you're kind of creating a contract so when you're creating objects in your system, they're going to follow that specified contract. They're going to say, I'm going to supply a get method and a set method, and I'm going to have these properties that you can look at. And it's really important to do that, even though there's no strict concept of an interface in JavaScript. And the reason being, because there's a lot of principles of robust software design that rely on interface contracts. And one of them is the open-close principle, and that one's really important. Open-close principle basically means that your system is open for extension, but closed to breaking changes. So this is why in the JavaScript specification, when we get a new version of it, we get kind of new stuff tacked onto it, but the old stuff still works.
Right. Yeah.
And that's an important concept in software design and evolving your software in a way that is flexible, that doesn't break existing software that depends on those features, right? So specifying a public contract for working with a kind of object is an important part of following the open-closed principle. And that's vital for, say, for example, you're creating an SDK, a public SDK, so that other developers can add on to your product, right? And they can develop extensions or things like that. If you go around changing things up, like if you change the interface without, and you introduce breaking changes and things like that, then you're going to break all those other people's software, right? So it's not very responsible. Right. So instead of doing that, I like to create a public API, which means that I encapsulate all the stuff that's hidden, that's private, right? I encapsulate all of that in a closure so that the outside world can't see it and get to it. Like, the outside world's not going to call the internal implementation, the utility functions that my methods rely on, right? Because that's implementation details that could shift and change, and then break their software later on.
True.
Right?
Okay. And is that what modules do, actually? Do they allow you to, kind of on the same note, hide certain secrets, hide global variables? I'll let you explain what modules are, actually.
Sure. A module is just a way of encapsulating functionality and then sharing that functionality everywhere in your app, or even among different apps. Like a lot of us produce open source modules and put them up on NPM, and then anybody can use them. Right, but part of specifying a module is specifying which parts of the module you're exporting to the public, right?
Okay.
And by export, I mean literally in node-style modules, you're doing exports dot something equals something else, right? So you're actually assigning things manually to the exports, right? And the same thing happens with ES6 modules. In ES6, you can do export default foo, right? And that's just, and it's only going to export that foo, right? Nothing else in the module.
Okay, that makes sense. And I wanted to go back and mention one more thing when you were talking about interfaces and contracts. That's one thing that really helped me wrap my head around it. When you say contracts, it's really literally like a contract, let's say with a bank, where maybe you want to get a mortgage or something like that, and the bank says, here's your contract, you have this amount of time to pay it, this is the interest rate, etc. And if you don't agree to those, we can't have a deal. You don't get any of the money for the mortgage. It's exactly the same principle when it comes to code. And I'm just curious, when you teach beginners, do they have a hard time with this concept? Because I definitely did. For some reason, I just could not wrap my head around it for a while.
Yeah, I think they struggle with it a little bit until I teach them about modules.
Yeah.
And then they see that, like, in order for something else to use this thing, it can only access this stuff that you publicly export, right? And then they kind of grasp the concept that that public export is a contract, right? So
wish I'd known you a few years back. You could have helped me.
Yeah, that's kind of the key to understanding it.
Yeah.
I think, is like when they can see a clear division between what's going on inside and what's being shared with the outside world. That clear separation is really the thing that tends to make this switch flip in their brains.
Sure. And then for modules, what made me understand it better is the whole namespacing concept, where really, if you don't have a namespace, how does your application know about what's inside of that namespace? Well, it can't. So you have to namespace it, bring it in, and then you can access it. That's one thing that really helped my understanding of it. So hopefully that helps somebody else out. All right, I want to talk about closures really quickly before we talk a little bit more about functional programming, which interests me quite a bit. But can you explain what closures are to us and why they're so critical to your successful application, as you say in your book?
Sure. So closures are just a way of exposing the state of a function to the outside world without let me rephrase this. Let's back up a little bit. Okay. I'll tell you a little bit about the mechanism first. So every function creates kind of a local environment where it has its own variables and things that you can access from inside that function, right? In JavaScript, you can pass functions back and forth, meaning that you can pass them as parameters, or you can return them from functions, or so a function can return a function. Okay. And you can assign functions to object properties and then return that object or pass that object into a function call as a parameter, as an argument, right?
I see.
So when I say that the state is exported, that means that so if you create a function and then you return a function from that function, that return value is being exported to the outside world so they can use it, right?
Okay, I see.
So what a closure does is it allows you, inside that function that you're exporting, it allows you to access functions in the parent scope, so the wrapping functions scope. So you can access a variable in the outside scope, use it inside this function, return this function, and then this function that you returned still has access to that variable inside of the outer function.
Sure, okay.
Does that make sense?
Yeah, it does. And I'll go try and put an example below the video as well, because I know some people are a lot more visual than listening to it. So I'll put a concrete example so they can compare back to it and look at it. I know I learn better that way sometimes, so I'm sure that will hopefully be helpful for some people as well.
Yeah, definitely. So what's interesting about closures is that you can create them inline. So you can actually, in JavaScript, you can write a function, and maybe this function takes another function as a parameter, right?
Okay.
And a function that takes another function as a parameter or exports a function is called a higher order function. So that's like a fancy name for something that it's just a function that takes a function, or a function that uses another function, right? Okay. Or returns another function. But what's important about this is that you can pass state into the function, into a function that you're calling, right? Mm-hmm. Through another function. So that function can wrap in some of the outside world, like some variables in the outside world, right? It can wrap that into another function and inject it into a function that's being called.
Is that hard to debug?
No, not really, because in your function call stack, you're going to see like a stack of different function calls.
Okay.
Right? And you can click in the debugger, you can click on any of those members of the stack and see what the values are. And the debugger will actually show you what's in the closure scope and what are local variables, and it kind of makes a distinction. So it makes it pretty easy to wrap your head around like what all the scope access is at that point in the program.
Yeah, otherwise I'm sure that could be kind of difficult to have to jump back and forth between different functions. If we didn't have something like that, that'd be a nightmare. Or it sounds like it would be anyway.
But stepping through the code in the debugger, it makes it really clear because you can see the sequence of what variables correspond with the parameters in the next function and so on. So, and it gives you, like I say, the closure scope of the currently running function. So if you're in your debugger looking at the currently running function, you can see all the local variables, but then you can also see all the variables that are available to that closure. So,
speaking of all these functions, functional programming is really interesting to me. I know it's been gaining a lot of popularity lately with all these, like Scala, for example, and Twitter moving to using Scala for some of their very intensive parts of the application and that sort of thing. How does JavaScript play a role into programming, or functional programming, I mean? What can you do with that?
So, because JavaScript has first-class functions, which means you can pass functions to other functions or return functions as values or assign them to properties and so on, that's really the key to making a programming language compatible with functional programming. So you can use techniques like function composition, which is just like it's passing the return value of a function in as an argument to another function. So these techniques, they're all available in JavaScript, but there's a really important concept in functional programming called immutability. And what that means is that once something is set to a certain value, that value can never change, right?
Okay.
So it's important to have immutability in functional programming because if anything is allowed to go in and change values at any time, then you can potentially create conflicts where multiple functions are depending on the same variable, but one of them changes the result of that variable and the other one is counting on that variable remaining consistent since like the last time that it accessed it, right? So when they start like playing with the same variable, it's kind of like two kids trying to play with the same toy at the same time, right? It's gonna lead to tears.
So how often do you use some kind of approach like this? How often is this beneficial, really?
I use functional programming all the time, every day. And I think that there are a couple of conflicting ideas that are really prevalent in JavaScript. One is object-oriented programming, and one is functional programming. And right now, the community is trying to like mash these things together, but they don't really go together all that well. Meaning that if you have an object with a bunch of state and a bunch of methods that act on that state, then and that object can get passed around between functions, you get that situation where there's different functions trying to rely on the same state, and they tend to walk all over each other and cause problems, right? So in functional programming, it's really important that that everything you're doing inside of the scope of your functional programming, it's got a reliable, consistent, immutable state. So think about, instead of thinking about objects where there's methods specifically designed to act on those objects, think about a utility belt of functions that can apply to any number of different kinds of objects, right? Because really, when you think about it, a lot of operations in programming languages are designed to work on a lot of different kinds of data. For example, in JavaScript, a string typically supports like all of the methods that an array supports. Like it can do all of the same operations. So you can actually call an array method on a string and it'll work, right?
I see.
And that's because a string is just an array of characters,
Mm.
Does that make sense?
Yeah. Yeah.
So when we're thinking about data types, we think of them as different kinds of things, but in reality, they're really modeled in the same way under the hood. And one very, very common thing in programming is you'll get a list of things, right?
Mm-hmm.
You'll get like a list of to-do items, or a list of songs in a playlist, or a list of employees in a company. And that's a very, very common abstraction. So any function that operates on a list could really work with a list of anything, right?
Mm-hmm.
And I think that's the core of understanding functional programming, is understanding that you can treat any kind of data the same way and use the same operations on that data, no matter like whether the data applies to an employee in an organization or a song in a playlist. Doesn't matter.
Yeah. So you're saying
operations work on both.
Sure, you're saying that we can take a function, we can create a function that will handle output or input from both strings and arrays at the same time. So we just need one function instead of having multiple ones that handle that. I see what you mean.
Yeah, you don't need a specialized function like for a string or an array or a song in a playlist or an employee or any kind of other, like car parts or whatever your program is working on. You don't need specialized functions to operate on lists of all those different kinds of things.
Sure.
All you need is like some generic utility belt methods that work on everything. And that's kind of what we got when we got the array extras in ES5, is we got some generic list functions that work on any kind of list, right? Mm-hmm. Mm-hmm. So functional programming is very much about using like really small, really generic functions that work on a wide variety of things. And if your thing that you're trying to manipulate doesn't exactly match what this function is expecting, you can use what's called a functor, which is basically like you take that data and you wrap it with an API that this generic function is expecting, right? Mm-hmm. And with that wrapped version of the data, then the operations can succeed. So and doing that with data, it's called lifting. So you take these specific functions that are designed to work on a specific type of thing, and you lift them into a generic function that works on anything that supplies the right interface for that function, right? Okay. It's called lifting.
Is that what you refer to as stateless functions and pure functions, or is that something else?
So pure functions and stateless functions are something else. Okay. A pure function is a function that only operates on its own local variables, and it doesn't change anything externally. So a pure function is not going to access global variables or mutate anything that gets passed into it.
I see. Okay.
So the idea of a pure function is that it does not have side effects, right? And a side effect can be any mutation of state that other things have access to, including things like drawing to the screen or writing to the console, right? So a pure function is basically, think of it as a function from algebra, right? Where it's like x equals x times 2, right? You're not actually changing the x that you pass into that function, right?
I see.
You're creating a new value. Mm-hmm. Mm-hmm. Does that make sense?
It does. And I guess that's why it's so important in functional programming, right?
Yeah. Immutability is really important, and I think equating it with like your high school algebra class functions is really the best way to think about it, because it doesn't matter, for instance, like how many times you call that x equals x times 2, how many times you like put a variable in it and get a result, right? If you use the same variable or the same value, if you pass that same value into that function, it's always going to return the same thing, because it doesn't rely on external state. It doesn't mutate any external state. So all it has to go on is the stuff that you pass in, the arguments that you pass into the function. If you pass the same argument in, it's always going to return the same value. So another thing that you need to be careful of is you can't use randomness as you can't like multiply something by a random number and expect it to be pure, because you're relying on external input that's not passed in the arguments. When you do math.rand, you're actually grabbing some state from an external source. It actually will take a look at things like the number of milliseconds since epoch time or something like that, and use that as a seed for the random number that gets generated. So you can't have any external inputs in a pure function. Only the values that get passed in as arguments.
I'm glad you gave that example. I would have never thought of that, to be honest with you. That's interesting.
Yeah, another thing, you can't look at what time is it right now, right?
Yeah.
Because the function needs to return the same value given the same inputs, whether it's called at 5 o'clock or 5:01, right?
That's very interesting. Never thought about it that way. That's really cool.
Yeah, and there's another interesting property of those kinds of functions. Pure functions exhibit what's called referential transparency, which means that you could literally replace that function call with the result, the value result of calling that function. So, for example, a compiler, if it knew the inputs and it knew the value that it would return, it could literally take the function call away and just assign the value, the resulting value, immediately.
Oh, wow.
Right? And this is another interesting optimization that can be made with any pure function. You can wrap it in a memoize function so that anytime you pass the same arguments in, it can grab a memoized result instead of running the function again. That makes sense?
That makes a lot of sense. That's crazy how that works.
Yeah, so it creates a lot of speed optimization. It also makes it easier to say, for example, you want to scale your app horizontally, and you've got a bunch of pure functions that are like written to encode video or something like that, right? You could take chunks of that video, chop them up, and spread them across an array of virtual machines in the cloud, right? And then grab the results from all of those and pull them back together. And the reason that it makes it really easy to scale horizontally is because they're not relying on any global scope. So you can just pass the parameters to each one and know that it's going to return the right result, right? And they don't rely on, any global state or anything like that. So that basically means you can chop your program up into little pieces and scale it horizontally as much as you want, and it works.
Is that the kind of stuff you're working out at Tout? For I know they do video.
So no, we actually used an encoding service in the cloud, but that service could do something like that.
I see.
And we would actually queue up jobs just like you would do if you were doing it yourself. You could queue up jobs and then send those jobs to various machines and then have the results come back. So we did something like that, but we didn't worry about how it was implemented on those service machines, right? We just counted on it, knowing that if you give it this chunk of data, it's going to return the right result for that chunk.
That's incredible. It's really cool stuff, really cool technology. And then you also talk about, let's see, currying. Yeah, that's what it was, currying. What can you talk a little bit more about that? I'm still trying to figure out. I think I've got a decent understanding of it, but I know it has a lot to do with functional programming as well, and that's one of the things you covered in your book as well. Can you give us a little bit more, maybe examples on how currying works and when to use it?
Sure. So when people say currying, they usually mean partial application, right? And partial application is basically you take a function that takes X number of arguments, right? And you return a function that takes a fewer number of arguments. And the way that you do that is you fix the value of one of the original arguments. So, for example, if you have a function that just multiplies X and Y, you could create a partial application of that function by passing in a fixed value for X. So, for example, you could say x is now 2, and you return a new function where x always equals 2 instead of taking a parameter, right?
Okay.
And then all you have to pass in is y. And then it's always going to double whatever you pass in. That's the partially applied x times y, right? So currying is kind of like that, except that in currying, with partial application, you can return a function that takes any number of parameters. With currying, you break it down until there's only a single parameter, right? And currying is used in things like trampolines, where you've got a sequence of things that needs to happen, like a repetitive loop, right? It just calls the same function and passes in the next parameter and returns a new function that has the next parameter in the right place, and so on and so on, until it gets a result, and then it passes back the result, right?
I see. Okay, that makes more sense. Yeah, I've seen it. I've seen it in Scala. I did just a little bit of work with Scala, and I saw that it was used in a few applications I looked at, but it never quite made sense. At least in some of the scenarios I saw, I guess they were made up, examples and things like that, which didn't make as much sense. But in that kind of situation, I could see where it could be pretty powerful, definitely.
Yeah. So just remember, the difference between partial application and currying is that in partial application, you fix a parameter or a number of parameters, and you return a function that can take any number of parameters. Like it just returns a different arity, right? Arity is how many parameters that function takes.
Okay.
So it'll take a function that with a large arity and return a function with a smaller arity, right? And currying always returns a function that takes one parameter, right?
Okay.
And the curry can be used for things like trampolines and other kinds of concepts where you keep repeating the function until you get a different kind of value back.
Okay. I've got a few more questions about just regular JavaScript concepts, and then we'll move on to talking about Node. But
Okay.
I'm curious, you mentioned test-driven development. There's a lot of very heated debate sometimes about this sort of thing. Do you use a TD or test-driven development approach personally?
Yes. And the reason for that is that I like to produce software that it provides evidence that it does what I say it does, right? So a lot of the times I tend to write tests before I write the implementation code. And that provides a lot of interesting benefits. For example, if you're writing your tests first, you're imagining the implementation of this thing from the perspective of the user. So you tend to come up with an API that's easy to use because you're approaching it from the perspective of a user. Whereas if you're writing the code, the implementation, without first thinking about the API, right? You have a tendency to do whatever is the easiest implementation or whatever is most convenient for you as a programmer, right? But once you've written something, you don't think about the implementation again, right? So you're optimizing for the wrong thing when you write the implementation first. You're optimizing for your convenience as a programmer writing that function for the first time. What you're not thinking about is that this function is going to be used 100,000 times more than it's going to be written.
Yeah.
Does that make sense?
It does, definitely.
So I tend to develop from the perspective of a user. I write my tests first, which means that I design the API before I start to write the implementation of the function. Right? And then I watch the test fail. It's important to do testing first because it'll automatically fail the first time that you run the test, right? Because
if not, there's a problem.
Right? One problem that people tend to have is they'll write a test that always passes, right? And you get a false positive result, but they don't know that they've written it wrong because they've never seen the test fail, right? So that's another major advantage of writing your tests first is you've got a stronger guarantee that the test you write is correct, is written correctly, right?
What kind of tools do you use in order to achieve this approach?
So a lot of people use behavior-driven development style, which is, BDD, which has libraries like should for assertions. And those tend to have fluent APIs that kind of read like English. I hate those. I hate those with passion because those fluent APIs tend to make tests way more verbose than they need to be, right? Typically, your best tests are equality tests. And the reason for that is because you say, I expect the result to equal this thing, right? Which means that your test itself can, if it fails, it can give you the expected value, the thing that it expected to see, and it can give you the actual value, the thing that you actually got, and you see a visual diff of what was wrong, right? Exactly how this thing failed. Like it might have expected an array of things and it got undefined instead, right? You can see that it got undefined instead of an array immediately before you even dive into the code. You can see what failed. So in my opinion, the very best test out there is just an equality check. And if you're expecting an array or an object, that would be a deep equality check where you actually go and get an object diff so you can see exactly what the values were inside the thing that you're expecting, right?
I see.
And the thing about equality checks is that they're really, really simple. They're really, really simple to read. They're really, really simple to write. And in my opinion, your test suite should not be 100 times more complicated than the implementation code. Your test code should be very, very clear and very, very simple. So I use Tape, which was written by Substack, who's written about 10 million, probably 10 million and one modules on NPM. He's really well known in the community because he's written a lot of very useful modules. But another thing that he's really well known for is the interfaces for all those things tend to be dead simple. So I favor test tools that are dead simple. They do only what they need to do and nothing else, nothing extra. I don't care about bells and whistles. When I'm working on unit tests, I don't care if it's printed to the console in pretty colors or if it like shows up with all this fancy stuff in the browser. I don't care about any of that stuff. All I care about is, did my test pass? And if not, what was wrong? What went wrong, right? So I tend to favor really, really, really simple tools. And it's kind of like the opposite of what what users think that they want when they're writing tests. People tend to adopt these complex test tools like Mocha or Jasmine or whatever the current trendy thing is, right? And current and trending and bells and whistles don't matter at all. The only thing that matters is that your software does what it says it does.
I've got some Jasmine right here.
That's where it belongs.
But hey, what's that?
That's where it belongs, in your cup or in your belly, not in your code.
Well, it's delicious. I can't argue that. Hey, speaking of fancy, there's this really popular platform that everyone seems to be talking about right now, and it's Node.js. What is it? Why is it so popular?
So I tell you why Node is popular. At Tout, we had a code base in Ruby, right? And then we rewrote chunks of that in JavaScript. And the JavaScript version ran a whole lot faster than the Ruby version. We had a big test suite written in Ruby. We rewrote chunks of that in JavaScript, and it literally ran orders of magnitude faster. Like the test suite in Ruby that would take like an hour to run. The test suite in JavaScript would take like 3 minutes to run, right? And there are a lot of reasons for that, but the primary reason is that Node is asynchronous by default, non-blocking by default. So when you start an asynchronous operation like reading to disk or reading from disk or writing to disk or reading from the network or writing to the network, you don't wait around for the results of that thing to happen to come back, right? Instead, you fire it off, forget about it, keep taking new requests, and then when it's time for that value to come back, it creates it's like an event listener, right? It just listens for the results to come back, and then it says, okay, now do the next thing, right? In Node, the default way to do that is called continuation passing. So you pass something a callback function, and when the result is ready, that callback function gets called with the result, right? But JavaScript provides a lot of other ways to do this too. Like the new ES6 has promises, which a promise is basically, think of it as a stream that only emits a single value, right? So you can say, I'm gonna create a new stream and return it, and then you can listen on that stream for results, right? It works very much like an event emitter too, except that with a promise, you don't have to hook up an event emitter first to get the first value. The promise is always going to resolve with a value or reject a value, right? And when you call after it's already resolved, it just returns that value to you, right? It just it just calls the callback immediately, right? So
well, that's why it's so useful as something like a web server or a chat application, something like that. Can you think of any other use cases off the top of your head?
There's a ton of use cases for promises. I just did a webcast recently called the ES6, the roadmap. And in that, I used promises to create a timer, right? I just like passed in a function and I said, I want this thing to fire, or I want this promise to resolve after such and such milliseconds, right? And I created a countdown timer by doing that 5 times. So it counted down from 5, 4, 3, 2, 1, blah, right?
Sure.
So you can use it for a lot of different things. You can use it for sequencing operations. You can use it for like anything where a resolution in the future can give you some valuable input, right? Okay. So, for example, network request. There's the new HTML5 API for fetch, the what working group fetch API. That just takes a URL and returns a promise, right? And that promise is going to either resolve with the thing that you fetched, or it's going to reject with whatever error came back, right? So yeah, promises are used for all sorts of things like that.
So do you pretty much just use Node.js now for almost all your projects, or does it have some things that it's a lot better at?
So for all of my kind of web-based application server-side needs, I use Node. And the reason for that is just it's really, really easy to make something that performs and scales very, very well. In other languages like Ruby, it is possible to create like that event-driven architecture using something called Event Machine. But then most of the Ruby modules are not written for Event Machine, and they don't work with Event Machine. So the interesting thing about Node is that non-blocking is the default way to do things in Node. So you're pretty much guaranteed to have all non-blocking APIs when you use Node, which is great because you're never tying up the machine waiting on a network request or waiting on a disk read or something like that. I say that it's the default way to do things.
Hold on a second. You're breaking up a little bit. The sound just went crazy. Hold on 1 second. Let's see.
Let me know when it's working again.
You sound like a robot. That's the only problem.
Do you edit this part out?
I can hear you, but you sound really bad. I guess we just got a little bump in the network or something.
Is it working
Hopefully
better
it passes.
now?
It's coming back. It's coming back. All right, there we go.
Great. So as I was saying, it's the default way of doing things in Node, but it's not the only way. You can still block if you want to.
Sure.
So it's important to look at the modules that you're using and make sure that they're not blocking. That's still important. But in Node, that's the default way of working. So you've got a much better chance of having something that works, that's performant.
And when you're building an application on something like Node, do you usually use Express? I know you mentioned it quite a bit in your book. Is that what you go to usually, or do you have other recommendations for this sort of thing?
Express is definitely my go-to, and that's just because it's got such a thriving ecosystem. It's the most popular framework for Node. It's not very prescriptive. It's really hands-off. It's really minimal. So there's a lot of stuff written for it, and you can use it in a lot of different ways. So yeah, that's definitely my go-to, is to use Express and build on top of that. But it's definitely not the only way to do things. And it may not even be the best way to do things, depending on what you're used to and what your coding style is. You might prefer something like Happy or something like Sails. If you're used to like Ruby on Rails, maybe Sails is more your thing. And there's some other things that are a little more prescriptive that people sometimes prefer. But I definitely recommend Express, just because if you're programming in Node as a career choice, you're going to encounter it eventually because everybody's using it. Well, not everybody, but just about everybody.
Having a thriving community makes such a big difference when you have something like this, like a library or framework or any kind of platform in general. Makes such a big
even
difference.
from just a documentation standpoint. A lot of the documentation for Node modules that you'll see is written using Express. So even just understanding how all the documentation for the modules that you're using works, knowing how to use Express it, and understanding the concepts in Express and the middleware and so on, is important just to wrap your head around all the modules that you're using.
Is taking a look at the documentation for these the best way you think to have a beginner get started with something like Node or Express, or are there any other better ways of learning?
Sure. Looking at documentation for modules that sound interesting, sound useful to use, definitely step one, right? Copy that documentation example, paste it into a file, and see if you can get it to run, right? And I say that because sometimes it's easier to take an existing example, watch it run, and then fiddle with it and change it in the ways that you want, than it is to come up with something on your own without having any knowledge of how the system works. You might end up spending a couple hours figuring out how to fire up an Express server and just get a response. And that's probably a bit of an exaggeration, because Express is really easy to use, and there's a lot of examples out there that are literally like 10 lines long for getting an Express server up and running and getting a response back. But if the basics are already established for you, they're already in place, and you can just start to fiddle with it and play with it and see the results of doing things a little bit differently, changing a value here or there, or creating a new middleware that processes the result in some way. I think that's a really good way for beginners to learn. I think that you don't really understand a thing until you've done it, right? So
especially in programming.
Yeah.
That's true for a lot of things, especially programming.
Yeah.
So
yeah.
I really want to cover. Yeah, perfect. And I really want to talk a little bit more about your cause as well. But before we do that, I've got two questions about scalability and speed that we talked about just a few minutes ago. Where, going back to Paul Irish and profiling your JavaScript and seeing the repaints and what's taking so long and stuff like that. Do you have any speed recommendations that you see happen over and over, just regular bottlenecks that a lot of people seem to overlook?
Sure.
Do you have any of those?
Sure. Start with the page load. Because the initial delivery is the number one. It's the most important thing for your app metrics. If your user has to wait too long before they even see the app draw on the screen, they're not going to stick around. They're going to think that it's broken and click the back button, right? Or go somewhere else or download a different app. So start with the page load, because getting that first page load to deliver quickly and to be usable really fast is the number one thing you can do for your app performance, for your app adoption, for your user success, trying to use your app, and so on. Getting that initial page load down is essential. Number one thing. And everybody takes it for granted and they go on to the next thing before they've optimized that initial page load. I'm telling you, take the extra time to really trim that initial page load as much as you can and make it as fast as you can make it. And that's going to contribute dramatically to the success of your application. More than anything else you can do, getting that page load really, really great is the best thing you could possibly do for your app.
Are you talking about manipulating the DOM too much or that sort of thing? Or are you talking about on a server level?
I'm talking about the first request that the browser makes to the server, and then it gets answered with the HTTP document and all the assets that come with it and everything that has to load before the user can actually start using the app. So it's basic. Think of the initial page load as the launch for your app.
Sure.
Right.
Sure.
So the user, even if your app is like a native app or something like that, the initial startup of that app is the most important factor. When you're considering the performance of your app, it's the most important thing to get right. Generally speaking, you can get everything else wrong, and if you get that one thing right, then you're doing pretty good, right? So start there.
So what gave you the idea to start this cause to end poverty? I know there's got to be some kind of story behind that.
Yeah, there is actually. Back in 2008, I was working on creative stuff, and the entire market, the entire creative market, just was destroyed, absolutely destroyed. I was, most of my clients were ad agencies or magazines, periodicals and stuff like that, and so they depended really, really highly on the creative market, and I was the supplier of creative materials for those things, and really, really fast, like almost overnight, I started noticing that my clients were getting laid off, or the magazines were getting shut down. And there was a whole blog that was just watching the death of the magazines, and there were several magazines would die every day, and this blog would update and tell you which ones were dead. And I saw more and more of my clients appearing on that roster, and so
that's not good.
Yeah, I was doing all right until like October 2008, and then after October, I got no payments until like the next April, something like that, from clients. So in the meantime, I was living on my savings account, and I was forced to sell my house, and then I was couch surfing with friends, and I didn't have a place to go. I had zero income because literally all of my clients were gone. Like half the companies had folded, and the other half had laid off my contacts there. So I one day I woke up and my Rolodex was completely worthless. So yeah, I got hit really, really hard by the market crash in 2008. Wow. And then a couple years later, fast forward to 2010, I've got a nice programming job, and early 2011, I'm walking along in San Francisco on my way to work, and literally tripped on a guy sleeping on a cardboard box right in the middle of the sidewalk. And he wasn't sleeping there to be a jerk. He was sleeping there because he had nowhere else to go. And that's a huge problem in the San Francisco area. You can walk around downtown and you'll run into hundreds of homeless people sleeping on the streets. There's thousands of chronic homeless in San Francisco right now. And this is a huge, huge problem. And there's no signs of it going away anytime soon in the Bay Area, just because there's a lot of factors contributing to the problem. Number one, the city is just conflicted. It's like this bunch of infighting trying to decide what to do in terms of new building development, and nobody can pull their heads out of it long enough to realize that they just have to build new things and build more housing, and then the supply and demand equation will kick in a little bit and things will start to loosen up a little bit. But another important thing that San Francisco could do right now is all those companies that are starting up in the Bay Area, they could save a ton of money on office space and start out as a remote-only office. So people are dialing in from their home instead of commuting into San Francisco. And if they just did that one thing, they'll save a lot of money. They'll be more productive. There's a study that shows that if your team is distributed, the software that you write, that the software that's produced by that team, has a higher tendency to be more modular. So even having a distributed team even contributes positively to the design of your software. So there's just a ton of good things that could be going on. Throughout the rest of the nation, there's not just the nation, it's really a global movement called Housing First, where they solve the homeless problem by giving homeless people homes. Just no questions asked. They just come in and say, I'm homeless, I need a place. And they get put into a program where they get supportive housing, they get supportive services, like they're addicted to drugs or something like that, they'll get addiction counseling. If they're untrained, if they need to learn some marketable skills, there's job training programs. And that's where people who code can really help. So I've got these online courses called Learn JavaScript with Eric Elliott. And one of the very first things that we decided when we decided to do these courses was that we're going to make them available for free to Housing First job training programs.
Okay.
So that people who are on the streets who need to learn a vocation and have valuable skills and be more productive in the marketplace, they have a really good place to start and learn those skills that they need, and they can go on and get really great jobs. So the current training programs right now in most of the places are things like training people how to do janitorial work, or something that's not going to give them enough money, minimum wage type jobs that are not going to give them enough money to raise a family and to really be productive members of society with a single full-time job. Right?
So you're going to teach them how to code instead, which can pay a lot more and stuff like that. But how can we help? How can somebody listen to this right after watching this video? What can they do to help this cause?
So there's a couple of things that people can do right away. One is, if your job is not remote work friendly, ask for remote work and lobby for remote work. Get together with your fellow employees who may be like-minded and want to save on their commute to work or something like that, and lobby for a remote-friendly culture at the company that you work at. And that helps in a number of ways. Principally, in jobs in markets like San Francisco, a lot of the problem for housing is that there's so many people who are trying to commute in that city to get jobs in that city, right? And if you work in a place like San Francisco or LA or New York City, where housing has been a problem historically, that's a good place to really lobby and try to encourage remote work culture. And just doing that one thing would help tremendously. Like if just half the companies in San Francisco that were software companies started doing remote only culture, that would create tremendous relief on the housing market in the Bay Area. So remote work culture is really important, I think. Another thing that you can do right away is you can actually sign up for my courses, and that will help us produce new content and make that content available for the homeless community. So that's a really major thing. Another thing you can do is train yourself well enough that you can be a mentor for other people who are learning, and then make yourself available to learning communities. Like, for example, you could become a member of our community and then help other students learn. And some of those other students will be the homeless students who are going through the Housing First training programs. So being able to mentor other people is really important. And it makes you feel good too, right? If you help somebody out who's having a hard time with something, it just gives you like I did something important today. You know what I mean?
Yeah.
It just gives you a really nice feeling. So it's kind of selfish too, because that honestly that feeling of helping other people and being productive in that way, it's, in my opinion, it's really the reason that we're all here in the first place, right? Being able to help each other is a huge thing. It's very fulfilling. So definitely do that.
Definitely. So if people want to help out and they want to get in touch with you, how would you recommend they do that? Or even just to thank for this episode and everything else? So
I think the most important thing that people could do, short of signing up for our courses, is they can reach out to JS Cheerleader on Twitter. It's JS_cheerleader, and she helps coordinate a lot of the efforts that are going on. Like she's producing a lot of the content, and she coordinates meetings. Like if there's somebody out there who maybe would also like to talk to us or would like to work with us in some way, or like if you have training resources to offer to the homeless training efforts, then we definitely are looking for people to partner with us on those efforts. So if there's somebody out there who has, like, especially like entry-level JavaScript training materials, is I tend to focus more on if the user has a little bit of experience with JavaScript, then I can take that experience and build on it and turn them into like super ninja level, like senior developer level, and even like engineering leadership level and architect level. So, but we're a little bit weak on the really entry level, simple JavaScript training. So people that have that kind of resource that they could share with us would be extremely valuable. So there's a lot of things that people can do. In fact, I wrote a blog post. Maybe we can share it. There's a blog post that I wrote on Medium. It's called The Recipe to Cure Homelessness or something like that. What is it?
I'm pretty sure I read that one. Yeah.
Yeah, the cure for homelessness. I read down at the bottom, there's like a checklist of things that you can do to help. So definitely look at that.
All right, Eric, and I want to wrap up by mentioning the programming literacy documentary that you and your wife are working on. JS Cheerleader is directing. There's a page I'm going to link below the video where you can sign up and receive, it's a newsletter, you can sign up and receive news via email. So I'm definitely going to link that below. Go ahead and subscribe to that. I asked you and you said there was no release date known yet, right? So
that's right. So the documentary is really important because it's really about the need to create better education opportunities for future developers, because literally almost half of the jobs that we have today are not going to exist in just a few decades. And so our kids, the kids that are going through school today, they're not getting programming education. 9 out of 10 schools in the United States don't have computer science courses. They don't teach people how to program computers. and it's really becoming a core literacy in the job market. So our kids are gonna like go out into the workforce, and they're gonna figure out that they're learning how to read and write for the first time, because it's really if you don't know how to code in a couple of decades, it's gonna be like being illiterate. So we're raising a generation of illiterate kids, and that's just horrendous. It has huge implications, and it's a future that we don't want to see come to be. So this documentary is going to show a lot of really cool things that are going on right now in some of the forward-thinking schools. They have, like robot soccer tournaments and like robot missile defender and things like that.
Yeah.
And there's just like really cool things going on that everybody should have access to. Every kid should have access to these resources right now, and they don't. And that's something that we definitely want to see changed. So JS Cheerleader has been really like the rally force behind this, and she's done a tremendous job of pulling together some really great resources. Like we've talked to some really interesting people from like, for example, Bill Scott from PayPal, who's a VP. He's in charge of like all the payment processing products. We talked to what's his name from so there's Vine, the creative force behind Vine that was acquired by Twitter. That's like the little videos and the tweets. And
she set up this interview
like
as well.
Really
so
interesting,
thank you for that.
People. So
yeah, definitely.
Oh yeah. So she's reminding me. We're still in production. We're looking for interesting people to interview. We're looking for music to license. I know there's a lot of. I'm one of them. There's a lot of programmers out there who are also musicians and music producers. So she's looking for music to license very actively.
I'm definitely not one of them. I'm sure there are plenty out there though.
Yeah,
but
there are a lot.
So if you're interested, reach out to JS Cheerleader on Twitter and check out the programming literacy documentary and all that good stuff. So Eric, I want to thank you for your time. Thank you for sharing your knowledge with us. I've really enjoyed this interview, researching it and learning more about JavaScript and that sort of thing. So thank you for your time. Thank you for everything. For those listening and watching, please leave a comment below to thank Eric for his time. And thanks all for watching, and have a wonderful day. I appreciate it.
Thank you. It's my pleasure.
Take care.
Honored to be here.